We'll do this in much more detail when we do linear algebra, but for now we're just going to look at how to place points on a graph. So there are times where we want to see visually the effects of changing a variable. So we've been looking at the lemonade profit calculation from the first video, and now we're going to try and see it visually, not just look at numbers. So typically when we're going to graph an equation, we'll have an independent variable and a dependent variable. The independent variable is what we change, and then when we change that, it changes some other value. Independent, and that makes it dependent. The dependent variable is dependent on the independent variable. They're sometimes known as explanatory variables and response variables. They have slightly different meanings in different contexts, but generally they're very similar. So when we're going to graph values, we typically link them together in coordinates. So here's the coordinate n comma p. The n value goes first and the p value goes second. We call them ordered pairs because the order is important. We always put n before p. And this way of displaying it is called a coordinate. Imagine co meaning two and ordinates being numbers. Now, when we look at this, we can make some conclusions. And once we've listed these in order, we can see that as n increases, so does p. We can also see that visually. So here's a graph. We've put n on the horizontal axis and p on the vertical axis. So when we're going to plot a coordinate, we go horizontally this many values and vertically this many values. So for our first point, we're not going to go left or right because n is 0. We're just going to go down. And here it is here, 0, 25. For our second point, we're going to go across 20 and then down 5. That gives us the point 20, -5, which is this one here. So when we sell 20 cups of lemonade, we make a $5 loss. Here's our break-even point. Oh, wait a minute. Then we had 30. So this is, we're going to go across 30 and up 5. So across 30 and up 5. And that shows us that when we sell 30 cups, we're going to make $5 of profit. Here's our break-even point. When we go across 25 and we don't go up or down, we've got our break-even point right here. And here's our first profit. When we sell 26 cups, we make $1 of profit. Now we can, if we join up all these points, we can see that they make a line, indicating to us this is a linear equation. And we'll be able to show that later on. But what it also does is it tells us for different values. We now know that for, what's this, 25, 26, 20, what's this, 20, 22, 24, 26, 28 cups, we're going to make, let's see, that's $1, $2, $3 of profit. Over here it tells us our profit. Each minor line is 2. And similarly, if we sell 10 cups, we will make -12, -14, -15. We'll lose $15. We can use the line for prediction. And as per our statement earlier, the more cups we sell, the more the profit increases, which was similar to this here. And thus we can see our relationship, our break-even point, our first profit, our startup costs before we sell any cups, and that with time our profit would increase. There's no sign of it decreasing. We can ignore the values of n minus n less than 0, so these ones over here, because negative cups in this case doesn't make any sense. And we'd be a bit skeptical of n equals 1,000 because we probably couldn't produce 1,000 cups in a day with the same profit margins. We'd need to employ more people, or we'd have to buy, ship the cups to us, or whatever feature happens. So this model only probably works for a range of values from 0 to maybe 50. So there you go. Looking at a situation, graphing it, and using it to find out some information about that modeled situation. I hope that's helpful, and I look forward to seeing you in the next one. Bye.